Every episode of this series so far has pointed at the same suspect, the air. Not this one. 444 million years ago, the ocean is about to lose something like 85% of its species in two short, savage pulses. The first of the big five. The first time animals ever died at that scale. And if you stood here at the start of it holding a gas monitor, it would not warn you about anything. So what does the readout say? At the beginning of the first mass extinction, carbon dioxide, thousands of parts per million. Call it 10 times what you breathe. Oxygen, below today's 21%, somewhere in the teens. Temperature, tropical seas not far off where they are now, and at the bottom of the world, an ice sheet the size of a continent. Nothing on that panel is a killer. That is the problem, because the number that ends the Ordovician was never on the panel. It is 80 meters, and it is measured downward in water. So where does the jump actually put you? On a low rock shore in the tropics, on a continent that will one day be North America, currently sitting on the equator. And the first thing that is wrong is the height of the world. Look inland, bare rock, gravel, and in every damp seam a thin green film. Mosses and liverworts, the first plants to get a grip on land. Ankle high at best. No trees, no grass, no shade anywhere on Earth. The horizon runs unbroken in every direction, because nothing alive on the surface of this planet is tall enough to interrupt it. Now turn around, and the whole world inverts. The sea is crowded. You have arrived at the peak of the biggest expansion of animal life the ocean had ever staged. The great Ordovician biodiversification event roughly tripled the number of marine families, trilobites working the sediment, brachiopods packed into beds, reefs, crinoids on stalks, and straight-shelled cephalopods meters long, hunting like living lances. And drifting above all of it, graptolites, colonies of tiny animals sharing one skeleton, most of them built as a narrow V. The land here is the desert. The water is the jungle. So what do thousands of parts per million actually feel like? Not like drowning, more like the worst meeting room you have ever sat in. In 2012, Usha Satish's team, and in 2016, Joseph Allen's group at Harvard, sealed volunteers into chambers, moved the carbon dioxide around, and watched their decision-making come apart. Crisis response, strategy, use of information, all sagging as the number climbed. 2,500 was near the bottom of their scale. The air you are standing in is several times that, so it begins as a headache behind your eyes inside the hour. Your breathing goes deeper and faster without you asking it to, because your blood is running slightly acidic and your body is trying to blow the excess off, and the oxygen is thinner than you were built for, so you breathe faster still, which does nothing about the carbon dioxide. The problem was never getting oxygen in. It is getting carbon dioxide out. You are not dying, you are being turned down, slower, clumsier, measurably worse at judgment, in a place where judgment is the only equipment you brought. So if the air only dulls you, what starts the clock? Food. Ask what you are going to eat, and the answer deletes half the planet. Nothing on land is food. No fruit, no seed, no grain, no leaf worth chewing, no animal ashore big enough to be a meal. The land food web does not exist yet. So you become a coastal animal by force. Every calorie you will ever get is in the shallows, within wading distance, and your whole life collapses onto one line, the water line, which would stay survivable, except the water line is leaving. In the early 90s, Philip Brenchley and colleagues pinned this glaciation down as short, sharp, and ice-driven. Ice stacking up on Gondwana, sitting over the South Pole, the scratch marks are in the rock of the Sahara today, water leaving the ocean to build that ice, sea level falling somewhere between 50 and 100 meters, call it 80, in a geological blink. And all of it, they pointed out, inside a greenhouse, carbon dioxide still high, the planet glaciating anyway, because the continent was parked on the pole and the young sun was fainter. Now put that drop on the coast you are standing on. These are epicontinental seas, shallow water lying across the middle of continents, gradients so gentle you could wade for an hour and never get your chest wet. 80 meters on a slope like that does not move the shoreline back a few steps. So who is doing this? Something has to take the carbon dioxide out of the air before ice can form. What? The obvious suspect got checked first. At Dobbs Linn, a stream section in southern Scotland, iridium is slightly raised right at the boundary, And iridium is the asteroid fingerprint, the thing that gave away the dinosaurs. But the rest of the kit is missing. No shocked quartz, no impact glass, no crater, nobody hit this planet. Whatever is doing this is far closer than the sky. In 2012, Timothy Lenton and colleagues put forward a suspect nobody had thought to call dangerous: the mosses. Here is the mechanism. Bare rock weathers slowly. Rock with plants on it weathers fast. Rhizoids hold moisture against the mineral, pump out acids, prise the surface apart, and chemical weathering is how this planet permanently removes carbon dioxide from its air. No continent had ever had a living skin before. Then one did, and Lenton's group modeled what that first thin film would do to the carbon budget, a drawdown deep enough to tip the world into glaciation. And the same process does a second thing. Weathering releases phosphorus. Phosphorus runs into the sea, and it feeds algae until the water underneath them runs out of oxygen. One cause, two weapons loaded together. So this is not a catastrophe that arrived. It is a catastrophe that grew. The most harmless looking life on the planet, that thin green film in the seams behind you, is the leading suspect in the first mass extinction of animals. You are standing on it. So what does 80 meters of missing water do to a living ocean? Peter Sheehan's synthesis describes it arriving in two pulses, and it is the second one nobody expects. Pulse 1 is the drought. The shallow seas drain off the continents, and the most crowded habitat on Earth simply stops existing, not damaged. Absent. Cold water pushes into the tropics and brings its own animals. A spare, cold-adapted set of brachiopods that spreads worldwide because the world it likes is suddenly everywhere. Then the ice melts and the water comes home. That ought to be the rescue. It is pulse 2. The returning sea floods back over the shelves, warm, sluggish, layered, low in oxygen, in places outright sulfidic. The habitat refills with water that cannot support what used to live in it. Jan Zalasiewicz has spent a career reading graptolites, and at Dobbs Linn the whole event is a few meters of black shale you can put your finger on. Below the boundary, the V-shaped colonies everywhere. Above it, gone, permanently. The graptolites that repopulate the Silurian seas are built as a single plain stick instead. The dominant body plan of an entire group, deleted and never rebuilt. For you, none of that is a statistic. It is one lifetime following the water out, and then the water coming back, and coming back dead. Hundreds of kilometers. That is the verdict. Not seconds, not degrees. A distance. The distance, the only thing keeping you alive, travels away from you while you stand there and watch it go. The waterline does not step back, it walks. Across a shelf that flat, 80 meters of depth is hundreds of kilometers of ground, and every calorie you have goes with it, and behind it the seabed you fed on last year is a drying flat with nothing on it that ever lived out of water. So you follow. There is no choice in it. You follow it out for as long as your legs and your luck hold, and then it turns around, and it comes back to meet you, and it is dead. There is nothing to stand on here. There is only something to follow. So why come here at all if the air was survivable? Every instinct says a cooling planet is a safer planet. This is the event that says no. Carbon dioxide went down, temperature went down, the direction everybody hopes for, and the ocean lost 85% of its species anyway. It was not heat that did this, and it was not poison. It was speed, and the fact that everything alive was already locked to a shoreline that moved. The argument is not settled either. In 2020, David Bond and Stephen Grasby argued from mercury in the rocks that volcanism and oxygen loss deserve more blame than the ice. What nobody argues about is the shape of it. Something changed the composition of this atmosphere faster than the planet's thermostat could answer, and the ocean paid. And we are not the first organism to do it. Cyanobacteria did it with oxygen. Mosses, if Lenton is right, did it with carbon. And they needed hundreds of thousands of years, and they were only trying to grow. Every episode of this series so far has pointed at the same suspect. Here the air was almost fine, and 85% of the ocean died anyway. The murder weapon was under your boots the whole time, and it was alive, and all it was doing was holding on to a rock.